Alright, this is 3.5, slope of lines. The central question, how can you use the slope of line to describe the line? The objectives of what you will be expected to learn or be able to explain is how to find the slopes of a line, how to use the slope to partition directed line segments, and be able to identify parallel and perpendicular lines. Alright, what you're going to be able to do now is find the slope. The slope of a non-vertical line is the ratio of the vertical change versus the horizontal change. You also call it here, this is the change in y over the change in x. Alright, so remember the m, that's our symbol for slope. It's also referred to as rise over run. The formula, if you're given 2 points like this x1, y1, x2, y2, it's the difference in the y's over the difference in the x. So it'd be y2 minus y1 over x2 minus x1. Alright, a little bit more some review stuff. Different slopes of a line. Remember that if it's falling from left to right, like this line J here, that's going down, that's going to give us a negative slope. Okay, and if it rises from left to right, like this line K, it's going up, that's going to be a positive slope. Okay, and if the slope is 0, it's a horizontal line like this line L right here. That's what we refer to as a 0 slope in Algebra 1. And if the slope is vertical, it means going straight up and down, like line N right here, that's going to be a undefined slope. Alright, now we got this example 1. It says find the slopes of lines A, B, C, and D. This should be some review stuff. So line A, the slope is going to be, remember we're going to use the y2 minus y1 over x2 minus x1. So looking at these 2 points is 6, 4, and 8, 2. I would do 2 minus 4 over 8 minus 6. 2 minus 4 would give me a negative 2. 8 minus 6 would give me 2, so my slope would be a negative 1. Alright, for B, line B, my slope here, I'm going to use 6, 4, and 4, 0. So for that one, I don't know, let's do 4 minus 6 over 0 minus 4. Okay, 4 minus 6 would give me negative 2. 0 minus 4 would be negative 4, so my slope would reduce to a positive 1/2. For line C, this slope right here, okay, now I know it's a horizontal line, so my slope is going to be 0, but just to review using the formula, we would do 4 minus 4 over 6 minus 0, and that's 0 over 6, which is just 0. Alright, for line D, this one's going straight up and down, so it's vertical, so that tells me I'm going to have an undefined slope. But to show you the difference of having 0 on the top and 0 on the bottom, alright, so let's look at this. I'm going to do 0 minus 4 over 6 minus 6. Okay, that gives me negative 4 over 0. This 0 cannot be in the denominator, so this one would be an undefined slope. Okay. Next we have partitioning a directed line segment. We've done this before. We did it on a number line, but we're going to take that idea of partitioning and we're going to put it in the coordinate plane. Alright, now for this example 2, it says find the coordinates of point P along the directed line segment AB so that the ratio of AP to PB is 3:2. So what I want is 3 parts to 2 parts. So there's a total of 5 parts. Okay, so the first thing we need to do, remember that when we did partitioning, we add the 2 parts. So really there's 5 parts. Okay, so what I want is 3/5, because I want this 3 to 5, so I want 3/5 of my slope. So looking at the rise and then looking at the run. Alright, so if I look at my rise, that's the change in my y values. So that's going to be 8 minus 2, which is 6. For my run, that's going to be 6 minus 3, which is 3. Okay, so what I want remember that my rise is my y values and then my run is my x values. So what I want is I want 3/5 of 3 and 3/5 of 6. Okay, so what I'm going to do is I'm going to take 3 for my runs. I'm going to do my x's first, times 3/5. Okay, that ends up being 1.8. Okay, and then for my rise, I'm going to do 6 times 3/5. Okay, which ends up being 3.6. All right, now, so what I want to do to find this point P that's up here somewhere, I'm going to take this number here, and I want to add that to my x value here. So I'm going to do 3 plus 1.8 to get my x value. All right, and then I'm going to take my y, and I'm going to add the 2 plus the 3.6 to get my new coordinates. So this is going to be 4.8, and this would be 5.6. So my point P is going to be at 4.8, comma 5.6. All right, so now we're going to look at identifying parallel and perpendicular lines on the coordinate plane. Important thing to remember, horizontal lines are parallel to the x-axis, vertical lines are parallel to the y-axis. Alright, for parallel lines, what you need to know is that for lines to be parallel, the slopes have to be equal. Alright, so if I want these to be parallel, what I need is my slope of the first line to be equal to the slope of the second line. Alright, next is for the perpendicular lines. The slopes of two perpendicular lines, it's going to be opposite, what we call opposite reciprocals. Or, I guess to be technically correct, we look at it as the product of their slopes being -1. So if I take the slope of the first line and I multiply that with the slope of the second line, I should have, the product should be a -1. Okay. What I mean by opposite reciprocals, if I say the slope of the first line, let's say that it's 2/3, okay, then my perpendicular slope is going to be the opposite. So if this one's positive, the second line has to have a negative slope. And then I take my numerator and I put it in the denominator, and I take my denominator and put it in the numerator. Okay. So this would be, if I multiply these two together, I get -1 as the slope. So let's look at some lines and see which ones are parallel, which ones are perpendicular. So kind of like we had before, we'll start with line A, and we want the slope of that one. So the slope of A is going to be 3 minus 2 over 0 minus -3, okay, which ends up being 1/3. If I look at the slope of B, that's going to be 0 minus -1 over 2 minus 0, so that's 1/2. Slope of C is going to be -4 minus -5 over 1 minus -1. That reduces to 1/2. Slope of line D is going to be 2 minus 0 over -3 minus -2, which would come out to be -2. Okay? So B and C have the same slope. They both have a slope of 1/2. So that would tell me line B is parallel to line C. And I'm looking for opposite reciprocals. So that tells me that B is perpendicular to D, and C would be perpendicular to D as well. Okay, so this line A is not parallel or perpendicular to any of the other three lines.